Hiya pirates, here we are. Our last topic here in thermodynamics is the whole idea of Gibbs free energy, which is the combination of H, S, and T put together to form G that is there. So, a couple of things to remember about Gibbs free energy. The Gibbs free energy is delta G is equal to delta H minus T delta S. Or if you want to put it another way, that delta G is going to be equal to the sum of the delta G of formation of the products minus the sum of the delta G of formation of the reactants. Right? Now, that one's really not important for us right now because we're not going to do any calculations here. But remember that delta H and delta S and T are all combinations here for the G. And so let's just make sure that we remember a couple of things about signs and so forth. So, first of all, let's cover delta H. If delta H is greater than 0, again, you're talking positive, then you're talking about an endothermic reaction from the system's perspective. If you are talking about delta H being less than 0, it is negative. It is exothermic from the system's perspective. And again, that's the whole idea of all of this, is that we wanted to put it in terms of the system. If delta S is greater than 0, it is positive. That means you increase chaos or disorder. You are increasing chaos. If delta S is less than 0 or negative, you are decreasing chaos or disorder. You're becoming more orderly if that is the case. Finally, if delta G is greater than 0, it is positive. It is a non-spontaneous reaction, meaning it doesn't go. If delta G is less than 0, negative, that means it is a spontaneous reaction. That is there. Based upon all of these clues that are given to you here in the problem, which of these circumstances for each of them is actually there? So let's take a look here. First of all, it says that the reaction is found to essentially go to completion. So if that's the case, that means it's spontaneous and it actually goes. So that is them telling you that it is a spontaneous reaction. Delta G is less than 0. Now, what about this? Well, in this one, we are going from the gas to a liquid. Well, anytime that you go from a gas to a liquid, especially if you're talking about the same stuff, you are becoming more orderly, or you are losing chaos. So if you are losing chaos, then your delta S is going to be less than 0 there. And then finally, what about endothermic or exothermic here? Well, we're going from gas to a liquid. So remember that in our temperature versus time graph here, if you start up here as a gas and then go down here to a liquid, you are going down the temperature scale. So you must be losing heat. To go from a gas to a liquid, you have to lose heat, and if you are losing heat, then you are talking about an exothermic situation. And so consequently, this guy is also negative. So based upon the information here in problem number 1, they are telling you that it is an exothermic reaction. Delta H is less than 0. It is going to see a decrease in the chaos, so delta S is less than 0, but the reaction actually goes, and so the delta G is also less than 0 in this case.